Gravity is a force that people have tried to understand for a long time. It binds us to the earth and keeps us on the ground and living. So what is gravity and who helped us understand this mysterious force? Galileo Galilei, of course. To more clearly understand who Galileo Galilei was and his contribution to physics, we need to understand the foundation his ideas were based upon. From early times, gravity was understood to be the tendency of most objects falling to earth. The Greek philosopher Aristotle was the first writer to attempt to explain gravity. He claims that objects fall because each of the four elements, fire, water, earth, and air, had their natural place, and these elements had a tendency to move back towards that natural place. He concluded that heavier objects fell faster in proportion to their mass. Aristotle's ideas were a great foundation, but as we all know, Galileo was the first to get a big picture of gravity. Galileo was born in Pisa, Italy on February 15, 1564. He was the oldest son of Galilei, a musician and a wool trader of the Italian Renaissance period. Galileo spent most of his childhood in Pisa till his family moved to Florence in 1574. In his early teenage years, Galileo attended the monastery school at Valbarossa near Florence. At the age of 16 years old, Galileo entered the University of Pisa to study medicine, but he was sidetracked by mathematics, which led to his major ideas that still impact our understanding of the world today. Galileo came up with the idea that gravity causes objects of different masses to fall at the same acceleration based off of an experiment where he dropped a feather and a hammer at the same time, at the same height. Now, people may think that the hammer will fall much faster compared to the feather due to the mass, but Galileo thought otherwise. This phenomenon can happen because in the absence of air resistance or other forces, all objects fall under the influence of gravity at the same rate, regardless of their mass. Through his experiment, he realized that falling objects follow a quadratic relationship, which means their speed increases as they get closer to the ground due to the force of gravity. In simpler terms, the term quadratic indicates that the change in speed isn't linear. It doesn't happen at a steady rate. Instead, the increase in speed is proportional to the time elapsed, and as the object falls, its velocity increases at an accelerating rate. This observation deepened our understanding of the concept of acceleration, which is defined as a change in velocity or speed over time. In the case of objects in freefall, this acceleration is constant and predictable, making it a fundamental concept in physics and engineering. Another experiment to prove his theory is when you use two marbles and they are dropped from different heights, one from 10 centimeters and the other from 70 centimeters. Both marbles will accelerate at a constant rate due to gravity, and they will both hit the ground. However, the marble dropped from 70 centimeters will have a higher final velocity compared to the one dropped from 10 centimeters. The difference in velocity is due to the constant acceleration that gravity imparts on both marbles, causing the marble drop from the greater height to hit the ground with more speed and potentially exhibit more force upon collision, which could lead to glass breakage. Nevertheless, it is important to note that both marbles undergo acceleration, albeit to different extents due to the varying drop heights. In summary, Galileo's groundbreaking experiments and ideas laid the foundation for our understanding of gravity and how objects fall. They continue to shape our understanding of the universe. Thank you for watching.